Good morning. Today, Anna are going to present your research in this doctoral meeting. And it is regular polysemy in large language models. I think you have 10 minutes for the presentation.
I think it was 20.
No. 10 minutes your presentation, and then we are going to ask some questions. I can read the summary, but I think Anna tell better than I the content of your research. And then when you want, you can start.
Okay, thank you, Eva, for presenting me. And so I'm going to present you my research with the current title, Regular Polysemy in Large Language Models. We will start with the plan of this talk. We will first mention the context of my work. Then we will touch on the main notions for understanding the title of my work. For those who don't have background in language science and linguistics, we will touch on semantics, polysemy, regular polysemy, and gradedness of regularity. Then we will establish what we know about these things in relation to human language processing and model processing. Then we'll present the actual experiments that we've done, the results, and future plans. And so the context. We've seen recently that large language models deliver very good results in many aspects of language processing, but because they are based on black box architectures, we don't know exactly how different language phenomena encoded in these models and how they represent different levels of language. But we can design and conduct probing experiments to access the internal model representations and find what knowledge is encoded in them on language. As a base and ground for hypothesis, we can use the findings of language-related disciplines such as cognitive linguistics, neurolinguistics, psycholinguistics, and this kind of research is meant to contribute to the explainability and accountability of the models, improve robustness and benchmarking. So starting with linguistics, this is the level of language at which I'm working. This is a branch of linguistics that is concerned with meaning of the expressions. It studies very different phenomena such as idiomaticity, compositionality, figurativeness, semantic relationships such as similarity, dissimilarity, hierarchical relationships, part-whole relationships, polysemy, etc. We are interested at the semantics at the level of words, rather than bigger expressions such as phrases, hence we work with lexical semantics. As we just mentioned, polysemy is covered by semantics. It's a form of ambiguity, hence the challenge, and it's a language phenomenon whereby a word is associated with multiple senses. We have, for instance, here an example of the word leg, which can mean a limb of an animal or a human. It can also mean a part of the furniture, as a table or a chair, and it also has a less frequent meaning, which is a part of a journey. For instance, we have here a trip Santiago-Paris with one stop in Barcelona, which is a trip of 2 legs. Importantly, polysemy implies relatedness of senses. Very often, the senses are not formed arbitrarily, but they are formed according to systematic alternations across the vocabulary. And these alternations have different degree of regularity. They can be more or less regular. Polysemy extends senses based on cognitive devices. The most important of these are called metonymy and metaphor. Metonymy is a cognitive device that is based on association or contiguity, as for instance in the example of the word glass, as the glass can mean translucent substance, essentially material, as in the sentence glass is made by melting sand, but it can also mean a vessel that is made of this glass, of this material called glasses, and in sentence, should I bring more glasses? Do we need more glasses? And it can also denote the content of a glass, as in a sentence, I drank a glass with my friends yesterday. And also this word is used to denote a measure. If you say, for instance, I only had one glass yesterday. It is obvious for all of us what measure we are talking about. And if we say about the sense of a drink, it's obvious that we don't consume any glasses, but we consume the substances contained in glasses. Another important device is metaphor. It's somewhat different. It is based on analogy or on implicit comparison. It's based on features shared across different objects that otherwise are unrelated. We already mentioned the example of the word leg, which can mean a limb or support of the furniture. By analogy, a table stands on its leg, like a human or an animal stands on their legs. Or for instance, the word antenna, that resembles a part of an insect, an organ of an insect, in its shape, form, look, and function. Importantly, regularity is graded. It is a continuous phenomenon. In some cases, like in the example with leg and antenna, it's very hard to find a word that has developed a base sense and hasn't developed the target sense within our pattern, body part, object part. There are many words that follow this alternation, this pattern, but there are also patterns that are less regular and productive. For instance, we do not often, in English, we do not often call animals with the names that we use to denote different kinds of humans. This is person-animal pattern. So why do we think that language processing by humans, the language representations in the human mind, in the human brain, why do we think that they have these types of structure, these groups, this regularity, irregularity, metonymy, metaphor, gradedness, relatedness, unrelatedness of senses? We think so because we have evidence from the disciplines that study language processing by humans. And these studies, essentially, they show that the types of ambiguities matter for us, for the language processing, that these different types of ambiguous words, they can elicit different priming effects, reaction times, reading difficulty, they elicit different signals from different brain areas, and so on. For this, the studies use different techniques such as brain scans, electroencephalography, reading experiments, eye tracking, reading time calculation, and studies on language learning in children and adults. And these studies show that, for instance, relatedness or irrelatedness of senses affect language learning when relatedness of senses makes things easier. It shows that humans can create and understand new senses on the fly during the language production or perception, and children can grasp and generalize from the early age regular polysemy patterns even without extensive prior relevant linguistic input. Interestingly, there is a growing body of research that shows that language models are also able for encoding fine aspects of language. They are, for instance, able to reveal the degree of polysemy of a word. They can somewhat meaningfully cluster word senses, and they can encode the meanings, etc. And so, contributing to this body, to this line of work, we conduct the experiments in a paper that we recently submitted. The experiments are based on a psycholinguistic study on humans, in the details of which we will not engage right now. But essentially, the study targets the effects of regular polysemy on the perception of novel, previously unseen senses. And we target these effects in language models. And we use standard NLP techniques that proved to have predictive psychometric power in previous research, which are surprisal and semantic relatedness. And so we obtain the model scoring using these techniques, and we conduct a correlational study to reveal how the model behavior compares to the behavior, to the processing by humans, and what effect linguistic factors have on this processing, such as word length, word frequency, and especially regularity degree. And so we derive several insights from our experiments. First of all, we find high correlation with human evaluators in the plausibility and the acceptability of novel senses derived from regular patterns in almost all of our models. Interestingly, masked models performed better in our experiments despite their smaller size than the autoregressive models. We also see the similarities in the model behavior towards word frequency, word length, and regularity, where the same as in the case with humans, word frequency and word length didn't affect the acceptability of our senses, but regular polysemy did. And we also discovered that the measures that usually show similarly competitive results in other research, surprisal and semantic similarity, in our experiments they diverge. For instance, we can see on this plot that surprisal from a mask and autoregressive model, they closely follow the purple line that represents human behavior towards different kinds of regularity. Different measures of regularity, while the results from semantic similarity, they move in a different way, and usually in other experiments, they show similar behavior. And we're going to continue our work in this regard. We would like to compare both both cognitive devices for sense extension, metonymy, and metaphor, because usually the studies in computational linguistics, they focus usually on metonymy, and we cover metaphors to fill this gap, and it will be interesting to design experiments that target the differences between two cognitive devices, because they know in human processing it matters, this difference. Also, we would like to explore more methods of probing, especially probing by prompting that we haven't done yet. And we also would like to bring the research to a more multilingual level, because we mainly work with English and with a little bit of French. But as we know from research, the structures, the semantic structures of polysemy, they are language dependent, they overlap across languages, but only partially. And it will be interesting to see, especially for multilingual models, whether they generalize the structures learned from English on other languages. And that will be it. Thank you for your attention.
Okay. Thank you for your presentation, because I am not expert in large language models, and I can understand your presentation, and then you are very good presentation. And then we are going to open a question, a turn of questions. I don't know if somebody from the audience can ask some questions.
Thank you for the presentation. It was really interesting. What do you expect for the multilingual experiments? Do you expect to see kind of the same result as for English, or different, or what do you expect?
For experiments with multilingual models or with other languages? Yes, with other languages. Well, we here depend a lot on the resources, because obviously for English we have a lot of studies and a lot of data sets where we can test many fine-grained aspects of language, but for other languages this is very scarce. For instance, we tried using French, but the dataset was 3 times smaller than the English one, and so results were not as good, but also very representative, and they gave us very good insights. And because we also need to be attentive towards our subjective input in the research, because there is a lot of research in polysemy on English, and US researchers also extrapolate these structures on other languages. And we actually need the research done on these languages to target these effects in the language models. I don't know if I make myself understandable. Because we can, for instance, take the patterns that I talked about, patterns of polysemy that we have from English research, and we can search for them in other languages and not find them, but that doesn't mean that they don't have regular polysemy, for example, and that the models don't work on them. We just need a very specialized research. And actually, outside from computational linguistics, in experimental linguistics, cognitive linguistics, this research exists. And the results say basically that the structures of polysemy, they largely overlap over languages, but the content of the structures is different. So while in English you can have, for instance, glass to have these types of recurrent reappearing structures, in other languages you don't find this. For instance, there are languages where you can use glass to denote a mirror and not a glass. And there are languages you can say rubber, which is a material that you use to denote a tire. And in other languages that wouldn't be obvious at all. And the English word tin to denote the metal container for tinned food, you do not find this kind of structure in this kind of content of the structure in other languages.
Any question? More? No, nobody asked. Then
Sorry.
it is my turn. Recently, I know linguistic Noam Chomsky, is a linguistic, point out that the use of ChatGPT could reduce the capacity of expression, reasoning, and ethics of communities, given that the algorithms that give it meaning have no substantial relationship with authentic human language. Do you think that with your proposed things you can decrease the gap between the human language and the computer language?
First of all, this kind of research, the probing experiments, these are rather diagnostic, exploratory analysis of how language is represented in language models. It can have a use, or maybe not. Maybe we don't want a model that is specifically trained to recognize and reproduce these kind of structures. Maybe this is not useful for us at all. So my research is concerned with rather diagnostic activities to see what is in there and how it is encoded, what language is represented.
Yeah, but like you're trying to extract the meaning, I suppose your purpose is to close to the human interpretation of the language.
Yes, maybe we don't need it in every use of AI, the very human interpretation of the language. Maybe we want it to work where we don't work very well. So.
Okay.
But obviously, yes, if we discover big similarities in how models process the language and humans process the language, we can say.
You may enrich the language models, and then maybe the future.
Yes.
In the future.
Yes, if you want a more human-like behavior towards these kinds of things, for sure.
In the future, maybe we can obtain a computers more with a behavior more closer to the human.
Yes, but first we need to establish what is close to human and whether it's already there or not.
Just a comment about that.
Okay.
I think like that too, in order to compare language models or computational models and human models, there are two perspectives. Okay. One of them is probing, but it's a paradigm where the work of Anna is situated. Language models can provide some evidence of things that are happening in language, in human language. So this is language models in this case are just devices that are used to understand the human language. This is one perspective, the perspective of Anne and many words. Another one, I think I don't know if it's the idea of Chomsky, if okay, human language can help to improve language models. In this case, we have to know better our abilities, cognitive abilities, linguistic abilities, in order to improve operations and mechanisms behind underlying language models. But this is another completely different approach.
But do you think that our brain is, we have many knowledge about our brain, about the behavior of our brain? I think our brain is richer than all large language models.
Okay, this is just an opinion. Okay, it's sure that language models use very basic operations like next word prediction, probabilities, things like that, and well, with probably some complex mathematical operations using matrix and operation on matrix. But the basic operations are probably much more basic than those that humans use, which are linked to compositional mechanism, which are probably more abstract, linked to operations that we use, or devices we use for other cognitive sense, like vision, hearing. We use other operations to understand languages that are probably not in language models. This is what I think.
I understand.
And maybe if we understand better how we understand language, natural language, we could improve language models. But what is
like
now
cycle.
amazing is that with this basic operation, like next word prediction, they now
it's like a loop.
They have an ability
There are dependence in one sense and in one direction and in another direction.
Yeah, we have to help language models to improve, and then maybe they, okay, I don't know if they can learn us something, probably, I don't know.
It's like the case of the eggs and the kitchen, which is first. Maybe the audience are some questions after this debate. Yeah?
Thanks a lot for the talk, Anna. Right now I was a little surprised when you said that maybe this is not useful at all, but I could think that probably you can think of applications. For example, just an opinion. Anything that contributes to the understanding of word meaning, especially this type of more figurative meaning related to metaphor, could be useful in downstream tasks like metaphor detection. Or, for example, I saw here a paper on dehumanization, and one of the patterns is animal person here in polysemy. But dehumanization would be treating people as animals, but not in this way, in another type of way. So if models are able to pick up this type of polysemy, then they would be able to tease apart dehumanization cases from this type of other phenomenon. So I bet you have thought of application cases.
Yes.
And I would be interested to know which ones, if you want to share them with us.
You bet?
That I bet you've thought of possible application cases, and I would be interested to know.
Yes, what I meant by usability is that this specific research of mine, it wasn't directed at a specific use at this point. It has a rather diagnostic, probing, exploratory meaning. But of course, this can be useful, because also for word sense disambiguation, for sense induction, because if we know that senses, they don't appear randomly, they're not appear arbitrarily, they're based across very productive structures across the vocabulary, and so they're more regular and they're more predictable. Of course, it can improve word sense disambiguation and sense induction for us. And yes, of course, with figurative language as well, because figurative language, it's also in many cases conventional, it's not random, it's also very regular. Conventional metaphor will be another interesting topic that overlaps with regularity, but only partially. Yes.
Yeah, so for example, yeah, thank you. So for example, in order to model a literary text, it might help to tease apart cases of conventional metaphor from cases of original new type.
Yes, there is the whole body research to do this.
To
Yes.
do that? Okay.
Yes, to discern different analogies, to see the differences between analogy, creative analogy, metaphor, creative metaphor. Yes,
Okay.
this exists as well. Yes.
Okay, thank you.
Okay, thanks. Any more question? No? Then I have to do another question if nobody asks. Okay. The UNESCO, the International Institution of UNESCO, last year made by the International Research Center for Artificial Intelligence, alerts that the social input of large language models about gender bias, okay, are intersected with another bias. What is the behavior or your proposal about this issue?
About the gender bias.
Yes.
So obviously the bias comes from the data that the models are trained on, and we humans produce this data ourselves. So do not produce sexist data, maybe. So then we don't have to trade the models on the whole internet of misogyny.
Yeah, but sometimes you can build an algorithm
Yes.
to clean the gender bias of the data sets.
Yes, you can do this.
Yeah?
Is it a question?
Well, give me your opinion. Give
Yes.
your opinion.
I think we can do it and we should do it. It's just,
For example,
it's another area of research that I'm not very informed about. But yes, there are recent regular events and conferences and workshops on text detoxification, for instance, of detecting different kinds of biases, including gender bias, because gender bias is not obviously only bias that is out there created by us.
for example, in English, English is a language quite neutral, and then maybe it has less gender bias due to the gender of pronouns or the gender of names.
Yes,
But there are another kind of gender stereotypes like professions or something like that. Maybe these techniques could be used to clean the data sets. Otherwise, the bias is perpetuated or amplified and maybe can go back in the future for the females' rights.
yes, this is, yes, I think you're right. And the fact that in English you don't have gender for the names of professions doesn't mean there is less bias in English language. It's not true. And the very basic examples is when you do basic class in NLP and you use popular libraries for mask filling and you put the profession of this woman is, and then you get nurse, I don't know, these kind of things, model, etc. and the profession of this man is, and then you get a doctor, I don't know, professor, etc. So these things are very much on the surface and you encounter them as soon as you start doing something about NLP in my very first classes in language processing. So yes, the fact that we don't have gender in the names of professions in English doesn't mean there is less bias.
Yeah. I encourage to go over in this line. Some months ago, I read an article, a paper, in which used the large language model to clean some race and gender bias in the clinical histories in United States. I don't know the result exactly, but the intention is quite good. Okay,
Thank you.
thanks. More questions? Yeah. No, nobody else. You can ask again.
Hey, I was thinking if we go back to your slide on the different behavior of autoregressive and masked, do you know more or less why? Why? Oh, you do?
Yes, thank you. Yes, it's because the nature of the task that we have here. Well, we use surprisal here mainly. Surprisal is the negative logarithm of probability of a word given its context, and in autoregressive models is only left side context, while in mask model is the both sides of the context. And in the linguistic experiment, psycholinguistic experiment that we are based on, humans, this is the design of experiment. The humans were asked to rate the acceptability of a novel sense on a certain scale, and they had context on both sides to evaluate the acceptability of it. And apparently this matters in our case because BERT-based models, they evaluate context on both sides to show you to output surprisal, while masked language models only on the left side. I don't know if it was understandable. The very task that humans performed for this experiment implied both contexts taken into the account to induce the acceptability of the words. And usually in this kind of experiments, the autoregressive models are used because these are usually reading experiments when we evaluate the difficulty of words, the processing of words, of sentences when humans read, and we, depending on the language, we read from left to right. And so usually in research, they use autoregressive models. So this is another contribution of ours where we actually compare the masked ones and autoregressive ones, and we see that even the bigger size of Yama, much bigger size, 8 billion, although it's a smaller one, it didn't help to improve the results, while Roberta outperformed by 12 points.
Oh, yeah, thanks a lot. Very.
Thank you.
More questions? Nobody asked. I have no more questions.
You had very interesting ones before. So.
Then we can close the event. Thank you very much for your presentation, and I am very happy because I can learn many things about this field that I am not expert.
Thank you for moderating.
Okay.